And today, the topic before us is mole concept in chemistry. This topic has been found to be what a disturbing one to students, and we say today let's try and make it more easier for our own understanding. Now, when you say mole is the major way of measuring chemical values, and it can also be said to be the amount of substance found in the what? In the Avogadro's number, which is 6.023 times 10 raised to the power 23. Now, when you are using mole to calculate, it has various parameters. Because of it is diversified, we can use different formulas to attain our mole. So come with me, let's explore the various parameters using different formulas to attain this mole. Number one, when it involves known masses. When it involves known masses. Now, when it involves known masses, you simply say mole, and we all know that mole is noted with small letter n. We can simply say mole is equal to what? Your mass over what? Your molar mass. And you know your mass is measured in grams, and your molar mass is measured in gram per mole. We all know. Secondly, when it involves solutions, you simply say your mole, which is noted with small letter n, is equal to what? Your concentration measured in what? Mole per dm cube. Mole per dm cube times what? Your volume measured in what? Dm cube. Now, third one, when at STP simply means what? Standard temperature and what? Pressure. You can say at STP, we can say mole is equal to what? Volume over what? 22.4, which is your GMV. The fourth one, when it involves number of particles. When we say number of particles, we simply mean elements, molecules, or atoms. It simply mean we simply solve it as what? Okay, let's say number of what? Particle. We simply say what? Mole is equal to what? Your number of particles over what? Your Avogadro's constant, which is 6.023 times 10 raised to the power what? 23. Sometimes you will just put, okay, let's do it like that. Now, the fifth one, when it involves ideal gases, and we all know that when we talk about the gas laws, we have the ideal gas and we have the rare gas based on their what? Their pressure and temperature, because there's always the deviation between two of them. So when it involves what? Ideal gas, you simply say what? Mole is equal to what? Your PV over your what? Your RT. And you know that your P stands for your pressure, your V stands for volume measured in what? Let me indicate that volume is measured in dm cube. So if you have been given questions in cm cube, just have it in mind that you divide by 1000 to attain your dm cube. Your R stands for your gas constant, and your T stands for temperature measured in what? Kelvin. Okay, now let's try our hands on some questions from the past question. This number one question: what weight of sodium chloride is needed to make 2.0 dm cube of 1 molarity of the solution? Now, you need to know that molarity is a unit of concentration. Just like we have mole per dm cube, we can also use molarity in concentration. So, now, first of all, the first thing you do when attempting a question is to bring out the parameter. State the parameter so you don't get confused. What was given? The first one that was given is what? 2.0 dm cube. So your volume is 2.0. The next thing is your what? Molarity, which is your concentration, is 1.5 molarity. This one is dm cube. So now, and we are asking for the weight. Now, you know weight simply means mass. First of all, what should you do? You first get your what? Your mole. Your mole, which is equal to what? You know when it involves solution, you simply say concentration times what? Volume. So what's your concentration? 2.0 times what? 1.5 to give you 3 mole. Now, but we have not gotten our answer. The question says what is the weight? Now, since we have gotten our mole, we have to recollect and take our mind back to the first formula we deduced, that when it involves masses, you simply say mole is equal to what? Mass over what? Molar mass. And we know that the molar mass of sodium chloride, sodium is 23, chlorine is 35.5. So if you join 23 plus 25.5, it will give you some 58.5. So I can say mass of chlorine is X. Mass of sodium